Good morning students. In last class we discussed electronic configuration of D block elements. Okay, electronic configuration of D block elements. In this class we discussed the variable oxidation states. Okay, variable means different. Variable oxidation states. Okay, one of the most important characteristics of D block elements is this variable oxidation state. Okay. Next, 3D D block elements 3D series and 4D series, 5D series, and then 6D series are present. We have 4 series in D block elements. We have 4 series. Okay. Next, these all elements can have variable oxidation states. Variable oxidation states, except first, that means 21, first scandium, first and last zinc. Okay, here first element is yttrium, here first element is lanthanum, this way actinum. Okay, next zinc, cadmium, mercury. Okay, this is the first elements and then this is the last group elements in D block elements. Okay. Next, D block elements can have variable oxidation states except first and last group elements. Okay, except first and last group elements. Okay, అది ఎందుకు అనేది మనం డిస్కస్ చేసుకుందాం. Okay. Next, in D block elements, the general electronic configuration is 1s, 1r2, n minus 1 into D, 1 to 10. We know. Okay, in D block elements, bond formation lo manaki both ns and n minus 1 d orbitals are participate చేస్తాయి. Okay, in D block elements, both ns and n minus 1 into d orbitals are involved in the bond formation. Okay, in D block elements, both ns and n minus 1 d orbitals are involved in bond formation. Okay, so this exists in variable oxidation states. అందువల్ల మనకి వేరియబుల్ ఆక్సిడేషన్ స్టేట్స్ అనేవి వస్తాయి. అవి ఎలా అనేది మనం చూద్దాం. ఓకే, ఇంకొకటి బేసిక్ పాయింట్ ఏంటంటే ఇక్కడ మనకి ఫస్ట్ గ్రూప్ ఎలిమెంట్స్, దట్ మీన్స్ ఎస్ గ్రూప్ ఎలిమెంట్స్ ఏంటి? హైడ్రోజన్, లిథియం, సోడియం, పొటాషియం, రుబీడియం అండ్ దెన్ సీజియం. The second group elements are barium, magnesium, calcium, strontium, barium. Okay, this is S block elements. Okay, in S block elements only S electrons are involved in the bond formation. Okay, in S block elements only S electrons are involved in the bond formation. Okay, but in case of D block elements, both ns and n minus 1 into d electrons are involved in the bond formation. Okay, here only s electrons are involved in the bond formation. So these elements are soft metals. Okay, all are metals. Okay, and then in D block elements, both ns and n minus 1 d electrons are involved in the bond formation. So these elements are hard metals. Why these are hard metals? In bond formation, both ns and n minus 1 d orbitals are involved. Okay, this is the basic point. And then next one, D block elements can have variable oxidation states. D block elements can have variable oxidation states except first and last group elements. Okay, because in D block elements elements, the general electronic configuration is this. Okay, in bond formation, both ns and f-1d electrons are involved. So there exist variable oxidation states. Okay, here I can write 3D series. Okay, what are 3D series? Here element, atomic number, electronic configuration. Okay, electronic configuration, and then finally variable oxidation states. Variable oxidation. Here I can take 3D series. 3D series elements endama. First one scandium, titanium, vanadium, chromium, manganese, okay, iron, cobalt, nickel, copper, and the last one is zinc. Okay, this is the 3D series elements. Okay, the atomic number is scandium atomic number is 21, titanium 22 and 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, and copper 29, and then zinc 30. This is the atomic numbers of these elements. Next, electronic configuration. Electronic configuration of scandium is, I write shortcut argon. Okay, argon means 18 electrons are completed. Remaining 3. 4s2 3d1. We already discussed electronic configuration of elements. Okay. Next, titanium electronic configuration is argon 4s2 3d2. Okay, then vanadium argon 4s2 3d3. Okay, and then chromium argon 4s2 3d4. Okay, and manganese argon. Okay, here chromium electronic configuration is 4s2 3d5. Okay, here one electron is excited. Why excited? If the orbital can have half filled or completely filled, then that particular element is more stable. So the electronic configuration is exist in this way. Okay. Next, manganese atomic electronic configuration is 4s2 3d5, and then iron argon 4s2 3d6. Okay, and then cobalt argon 4s2 3d7, and nickel argon 4s2 3d8, and copper argon 4s1. Okay, chromium and copper is different. Argon because if lost these 3 electrons, then it get argon configuration. So it gains stability. So it lost 3 electrons. Plus 3 is the plus 3 is the oxidation state of the scandium. And then next to titanium. Okay. If titanium can lose 2 electrons from S. Okay, titanium can lose 2 electrons, then it get 3d2 configuration. Okay, plus 2 and plus 3 and plus 4 can exist. Okay, that means if this titanium can lose 2 electrons or 3 electrons and 4 electrons also, that means chance is 2 electrons are released or 3 electrons are released or 4 electrons are released. Okay, here vanadium, the atomic number is 23, electron configuration is this. If this vanadium can lose electrons, that is 2 from S plus 2 or 1 from D, that is plus 3 oxidation state is exist, 2 is in S and 1 is in D. Okay, and another chance is plus 4 and plus 5. Okay, that means clear. Argon 4 is to 3D, 3 is the electronic configuration of vanadium. Okay, here 2 electrons are present. Here in D orbital only 3 electrons are present. Okay, if if vanadium can lose 2 electrons from S, that is plus 2. Okay, 1 electrons from D, that means this 1 electron from D, that is plus 3 oxidation state is exist. 2 is in here S, 1 is in D block. So this is plus 3 oxidation state. This also removed. Next, plus 4 means these electron also removed. So plus 4 exists. And remaining 1 electron is present. If lost this electron, then this exists plus 5 oxidation state. మనకి chances ఉన్నాయి అని చెప్తాను. Okay, next chromium atomic number is 24, electronic configuration is this. That means 4s1 3d5. Here 1 electron is here, 5 electrons are present, 1 2 3 4 5. The oxidation states possibilities are here 1 electron is released. Here electron is released from S, then this chromium can get the configuration 3d5, that is off-filled. So plus 1 is exist. Next, if the element can lose 1 electron from D, then this exists plus 2 oxidation state. Okay, if this element can lose another electron from D, then there exists, ఇక్కడ నుంచి 1 electron remove అయింది, so plus 1 charge exist అవుతుంది. ఒక electron ఇక్కడ నుంచి remove చేస్తే plus 2 charge exist అవుతుంది, and then we remove another electron from D, then there exists plus 3 oxidation state. And another possibility is if I remove this electron, then plus 4 oxidation state is released. That means 4 electrons removed. Okay, and this electron is removed, then there exists plus 5 oxidation state. And finally this 1 electron also removed, then there exists plus 6 oxidation state. Okay, next manganese. Manganese atomic number is 25. This is the electronic configuration of manganese. Here I can remove plus 2 from S. Okay, I can remove 2 electrons from S. Okay, next plus 3, one is D. Plus 4, plus 5 and plus 6 and plus 7 is the oxidation states of this manganese. Same way, argon, iron, the atomic number is 26. This is the electronic configuration of iron. Argon 4s2 3d6. 4s2 means 2 electrons in s block, s orbital. Okay, and 6 electrons in d. 1, 2, 3, 4, 5 and remaining 6. Okay, in this case I can remove 2 electrons from s. Okay, 2 electrons from s, then there exists plus 2 oxidation state. Okay, and another possibility is then I remove these 2 are removed, plus 2 oxidation state is exist. Okay, then I can remove 1 electron from D, then there exists here 2, here 1. So plus 3 oxidation state is possible in Fe, and I can remove also another electron, that is plus 4 oxidation state is exist. Okay, and can I remove another electron, then plus 5 oxidation state is exist, and remaining this electron can remove, and then plus 6 oxidation state is exist. This electron is not removed. Why? This is pair up. Okay, in S 2 electrons are removed, but in D orbital paired electrons are not removed. Okay, so plus 6 oxidation state is exist only. Okay, then cobalt oxidation state is 4s2 3d7. 4s2 3d7. 4s2 3d7 means here 2. 1, 2, 3, 4, 5, 6, 7. This is the electronic configuration of cobalt. Okay, here I can remove 2 electrons from S, then there exists plus 2 oxidation state. Okay, next I can remove 1 electron from D, then there exists plus 3 oxidation state. Okay, then I can remove another electron in D orbital, then there exists plus 4 oxidation state, and I remove this unpaired electron, then there exists plus 5 oxidation state. Okay, remaining electrons are not removed because this is paired. Pair up avadam valla దీంట్లో నుంచి ఉన్న electrons అనేవి తీయడం జరగదు. సో కోబాల్ట్ లో మనకి ఎగ్జిస్ట్ అయ్యే ఆక్సిడేషన్ స్టేట్స్ ఏంటి? ఎగ్జిస్ట్ అయ్యే ఆక్సిడేషన్ స్టేట్స్ ఏంటమ్మా? +2, +3, +4 and +5. Okay, and then nickel electronic configuration is 4s2 3d8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can remove 2 electrons from S, then there exists plus 2 oxidation state. Okay, and then I can remove 1 electron from D, then there exists plus 3 oxidation state. Okay. can remove these two electrons from S, then there exists +2 oxidation state only. Okay, zinc can exist only +2 oxidation state. Okay, this is completely filled, so we don't remove this. Okay, next, variable oxidation states means the D block elements can exist variable oxidation states. Variable means different. The D block elements can exist variable oxidation states except first and last. Okay, first and last group elements in each series. Why? Because why means because in this first case, if lost these 3 electrons, then it gains organic configuration. It is more stable. So +3 is possible only. Here, if lost 2 electrons, then exist completely filled electrons D and argon configuration. Okay. Next, here +2 also exists. I can remove +2. Okay, +2 also exists, +3 also exists. +3 is more stable than scandium +2. Why? In scandium +2, only S electrons are removed. Okay, but in scandium +3, 3 electrons are removed. Then it gets argon configuration. It is more stable. Okay. Next, in titanium +2, +3, +4 oxidation states are exist. Okay, that means titanium +3 is less stable than titanium +4. Okay, in titanium +2, +3, +4 oxidation states are exist, but titanium +3 is less stable than titanium +4 because if I can remove 3 electrons, then it gets 4s1 configuration. Then it gets argon 4s1. Okay. If I lost 4 electrons from this titanium, then this titanium can get argon configuration. So it is more stable. So titanium +3 is less stable than titanium +4. Next, in manganese, okay, the variable oxidation states are all. Okay, in this case, Mn +3, okay, Mn+3 is less stable than Mn +2. Mn+3 is Mn+3 is less stable than Mn+2. Why? Because if I lost 2 electrons from S, then it gets half-filled configuration 3d5 and argon. So it is more stable. So Mn+2 is more stable than Mn+3. Mn+3 means 2 electrons from S and 1 electron from D. Okay, so unstable. Mn+2 is more stable. Why? Because 2 electrons are removed from S orbital, then it gets argon and 3d5 configuration. It is more stable. Half-filled, when the element can have half-filled and more completely filled, that element is more stable. Okay. Next, this is the variable oxidation states of D block elements in 3D series. Okay, D block elements లో మనకి 3D series కి variable oxidation states ఇది. Okay, మనకి దీంట్లో అన్ని వాటిలో కూడా the common oxidation state ఏముందమ్మా? అన్ని వాటిలో మనకు వచ్చిన common oxidation state ఏముంది? +2. Okay, in D block elements, in 3D series, okay, +2 oxidation state is the common oxidation state. The common oxidation state in this series is +2. Okay, next. The maximum oxidation state entama? The maximum oxidation state is +7. Then manganese. The maximum oxidation state in 3D series is +7. Okay, the maximum oxidation state in 3D series is +7. Okay, but in 4D and 5D series, +8 oxidation state is more highest oxidation state. Okay, in 3D series, the maximum oxidation state is +7 in manganese. Okay, but in case of 4D and 5D series, +8 oxidation state is maximum oxidation state. Okay, this is in case ruthenium and osmium. Okay, ruthenium and osmium elements మనకి +8 oxidation state అనేది exist అవుతుంది. It is more stable. Okay, it is as RuO4 and osmium O4. Okay, we can find out the oxidation state of ruthenium oxide. Okay, I can find the oxidation state of ruthenium. So I can take X plus 4 oxygens are present. So 4 into the oxidation state of oxygen is -2 is equal to 0. Then X is equal to +8. Osmium O4 same. Okay, in 3D series the maximum oxidation state is +7 in manganese, but in case of 4D and 5D series the maximum oxidation state is +8 in case of ruthenium and osmium. Okay, that is exist as ruthenium O4, ruthenium oxide and osmium oxide. Okay, students.